Hello, Mr. Collier here. This is the third video in the Lab 6C series. This is the lab about collisions, which is going to involve some momentum calculations. And that's what I'm going to show you in this video, how to calculate the momentum. First, a little reminder, this was the lab where we had the flat track and a stationary car and then another car slam into it. So the orange car with the rubber band goes through the photo gate and the blue car gets run into, and there's a transfer of momentum. So I'm going to do the calculations for just the first scenario with the 0, 0. The orange car is going to be car A and the blue car is car B. The data I'm going to be using is from the part 2 video, if you want to use that as well. So 0.0097 seconds was our A time, and 0.103 was our B time. So we want to calculate the speeds. So to do that, it's the same as it always is. 1 centimeter divided by the A time gives you the A speed. And when you divide that out, you get 103 centimeters per second, and that's rounded to 3 significant figures. For our B speed, we're going to do 1 centimeter divided by the time B, which is 97.1. And that's how you get your speeds, which you're going to need for data table number 2. Here's the slightly more challenging part. Now we're going to be calculating momentum. And to calculate momentum, you need the mass and the velocity of the car. So first, let's take the mass data. So from our part 2 video, we got that the car A with 0 marbles is 58.23 grams. Now we need to convert that to kilograms because all momentum calculations are done in kilograms. So we're going to slide the decimal 3 places to the left, and we get 0.05823 kilograms. Our car A speed was in centimeters per second, but again, to do momentum calculations, we need to convert that to meters per second. So I'm going to slide the decimal 2 places to the left and get 1.03. Don't forget to do those conversions from grams to kilograms and centimeters per second to meters per second before you do your actual momentum calculations. The equation for momentum is momentum equals mass times velocity. So now we've got a mass and a velocity. We can just simply multiply them. So 0.05823 times 1.03 gives us a momentum of 0.0600. So it's not very much momentum, but that's the momentum. And a note, that was 5997, I think, and I had to round it to get 3 significant figures. The mass of the B car was 59.11 grams. We're going to convert that to kilograms by sliding the decimal 3 places to the left, which gives us 0.05911. We need the speed of car B, which again is from the data table above, 97.1 centimeters per second. We're going to convert that to meters per second by sliding the decimal 2 places to the left. Momentum, again, mass times velocity. We're going to multiply those 2 values to get the momentum. Now, in this first trial, our speeds were very similar because both cars had the same mass. And so when the energy was transferred, all of that speed was transferred. Now, you might notice that speed B is a little bit less, and that's going to be because not all of that energy is perfectly transferred. In a perfect closed system, all of the momentum is transferred from one car to another. But in actuality, some energy is going to be lost to friction, some energy is going to be lost when the rubber band bends, and so you're not going to have this perfect conservation of momentum. You are going to lose a tiny little bit. And what you're going to see is that the momentum is a little bit different for cars of different masses, right? Because when the mass is different, the momentum is different. And you're going to continue on your calculations. You can use this video as a reference for what numbers to put where. And you can go back and get the data from part 2 if you need to, or you can use your own data that you collected in class. Good luck.